Hello, viewers. You're welcome back to my channel. So, if this is your first time, you're welcome. In this video, we'll be looking at rational inequalities. Rational inequalities. So, what are rational inequalities, and how can we solve rational inequalities? So, rational inequalities, these are, you can say these are inequalities that involves what? These are inequalities that involve rational functions. And what do I mean by rational function? It means you have in the form of, let's say, nx over what? D of x. So where nx and d of x are polynomials. So you have, like, when we talk of rational number means it's a number in the form of p over q, right? Where p and q are integers and q is not equals to 0, right? But in this case, when we talk of rational function, we're talking of function where both n and d are polynomials. So let me just give us examples. So let's see examples. You have, for example, you have something like 1 over x plus 1 minus, okay, let's just say it's less than equals to 1. So this is an example of a rational function, rational inequality. We can also have, let's say, x squared minus 3 over x squared plus 1. Let's say it's greater than 0. This is also another rational inequality. And we can have something like this. And let's say minus 3 less than equals to, let's say, 1 if possible. So all these are examples of rational inequalities. Why is it rational? Because you have a polynomial divided by a polynomial. Why is it an inequality? Because you have inequalities. And here we can even make it more complicated, and we say less than equals to, let's say, maybe 3 over x. This. So how do we solve this type of problem? How do we find the solution set? To do that, we need to use some guidelines. So the first thing is that we will write the inequality in the form of what? This one. So what does this mean? This means that you will have the inequality. So we can have the what? The rational function on the left hand side. You have the inequality in the middle, and you write 0 on the right hand side. So this is the first step. Then the second step will be to factor both the numerator and the denominator. Remember, we said the numerator will be a polynomial, the denominator will be a polynomial. So we can try to factorize it. Then we find what we call, we just call it, you can say the zeros. We find the zeros of the what? The numerator, and as well as the zeros of what? The denominator, which we somehow call the critical values. Um, It's just, yes. So we can just call them the zeros of the numerator and the zeros of the denominator. But number 4 is very important. We have to put an open circle around the zeros of the denominator, because it's coming from the denominator. We need to open it. So then we will use our table to do the sign test. So let's just take a few examples, and we'll illustrate how to use these guidelines. So for example 1, this is We have example 1, you have 5. So we have 5x minus 9. For 5x minus 9 over x minus 5 less than equals to 3. So the first thing to do, just look at the following step. The first step is to what? Is to make sure we write everything on one side and we have 0 on the right hand side. So to do that, we just need to transfer this here. So we can transfer so that we have 5x minus 9 over what? X minus 5 minus 3. This will be less than equals to 0. So this is the first step. Then now we need to rewrite this. This we can write as what? 5x minus 9 over x minus 5. This we can multiply this by what? X minus 5, so that we can make the denominator the same on this side. So here we just multiplying by x minus 5. It's like multiplying by 1. Now we have the same numerator, so this will be 5x minus 9 minus, this will become 3x plus 15 over what? X minus 5. This is less than equals to 0. Now we can simplify the numerator so that you will have 2x. 5x minus 3x will be 2x. And we have minus 9 plus 15, which should be 9 plus what? Plus 6 over x minus 5. So this is like step 2 now. So this is the whole of this. This is step 1, which is our first guideline. So all of this now, we can still factorize this. Now we are factorizing the numerator and the denominator. Here we can write what we can have here is we can have take 2 as a common factor. So you have x plus what? Plus 3 over x minus 5. This is still less than 0. Now we have finished step 2. So with step 2, it's just from here to the whole of this. We can say it's step 2 because we are trying to what? To factorize the numerator and the denominator. Then now step 3, what do? We take the zeros of the numerator, which is x equals to minus 3, and the zeros of the denominator, x is equals to 5. Right. Then now we can go to the table and have the number, our number line. So what we need to do is we have only how many zeros? We have 2 zeros, one coming from the numerator, which is the smallest. So it's going to be minus 3, and one coming from the denominator, which is 5. Now, always open the one that is coming from what? The denominator. So 0, 5 is coming from the denominator, so you have to leave it open because it's coming from the denominator. Then minus 3 is coming from the numerator. This we can leave it closed. You can leave it closed. Why? Because you have equal to 0. So if this is just strictly less than 0, then we need to open this too, because at minus 3, if you put minus 3 here, you will have equals to 0. So now we can add our factors. What are the factors? We can use 2x plus 3. It's not a problem. We can as well forget about the 2 because 2 is just a positive number. So now we need to take our test point. How do we take test point? You take a number between minus infinity and minus 3. We can take minus 4. If you substitute minus 4 here, you have minus 4 plus 3. It's a negative number. Minus 4 minus 5 is also a negative number. So since we are dividing, it means we are dividing a negative by a negative. The result will be positive. Between minus 3 and 5, we can use 0. If we take 0 and substitute here, x plus 0, this will be what? Positive. X minus 5, this also will be negative. So we will have negative. It means you have a positive here and you have a negative in the denominator. Then if you take a number greater than 5, should be 6. If you add substitute 6 here, it will be 9, which is positive. 6 here, also positive. So this is also positive. Why is it positive? Because you have positive, positive. It means, look here, we're taking the quotient of two positive terms, which is also positive. So I think we're done. And now we just take the interval where we have greater equals to 0, and that will be this interval, these two interval. So it means our solution set will just be from minus infinity to minus 3 close, then union. Now 5 is open, so we go from 5 to infinity. All right. Okay, so if you are new to my channel, please don't forget to subscribe, like, and also share my videos. Now let's go to the second example. Now the second example is we want to solve what? We want to solve 4x 4 over x minus 1, right? Greater than what? 3 over x. So what do we do in this one? Here, the first thing is to what? To transfer to the other side. So we have 4 over x minus 1. This is minus 3 over x, right? This will be greater equals to, there is no equality here, so this will just be greater than 0. All right. Now, what is the next step? The next step is to try to simplify the left-hand side, and that we can easily do by trying to get what? The LCD. We want to make the denominator to be the same, so we can do that by multiplying what? We can multiply this term by x over x, and we can multiply this one by what? X minus 1 over x minus 1. So just stay with me. This is what I'm doing here. We're just multiplying this. So here will be 4 over what? X minus 1. And here will be just 3 over x. This is still greater than 0. So this is just to make the LCD, the denominator, the same. This will be 4x minus 3 into x minus 1. Then everything in the denominator will be x minus 1. They should be greater than 0. So we can simplify this to be 4x minus what? 3x plus 3 over x minus 1 greater than 0. So what will this become? Let's continue here. 4x minus 3x will be just x plus 3 over what? X over x minus 1 greater than 0. So now we're done. We're done with I think the third step now. So now we need to find the what? The zeros, which we call the critical values. So we take x to be what? Minus 3, and x to be what? 0, and x to be what? 1. So this is what we need for the table. This minus 3 is the 0 of the numerator. X equals to 0 and x equals to 1 come from where? the denominator. So now we can have our table. Now what do? We arrange the zeros, starting with the smallest. So the what will be minus 3, right? And we have 0, then we have 1. We can have our lines this way. Now, just like I said earlier, the zeros coming from where? Coming from the denominator. You have to open them. So it means you have to open at where? At 0, and also at where? At 1. But let's look at the 0 coming from the numerator, which is minus 3. Minus 3 also, we need to open it. And the reason why we're opening it in this case is there is no equal to 0. Unlike the first example we did, we closed the 0 coming from the numerator, because we had what? If you look at here we have less than equals to 0. So there is equal to 0. And that's why we closed minus 3. Okay. But here, there is no equals to 0. So since there is no equal to 0, it means we need to open minus 3. Now let's put our factors, which are x plus 3. Then what? We can have it x, then x minus 1. So these are the 3 factors. So let's take test point. This is minus infinity. This is infinity. You start, take a number between minus infinity and minus 3. You can take minus 4. And if we take minus 4, what do we get? Minus 4 plus 1 is going to be a negative number. X is minus. Minus 4 minus 1 is also negative. So this will result to what? Negative. Because why is it negative? You have, this will be minus. If x is minus, you have minus here, minus here. So you have a negative number divided by a positive number. All right. So now between minus 3 and 0, what do we have? We can take what? We can take, let's say minus 1. It's fine. If you minus 1 plus 3, this will be plus. X is minus, so it's still minus. Minus 1 minus 1 is also minus. So the result is going to be positive. You have 2 negative, 1 positive. If you take the quotient, because this one is coming from the numerator, the 2 here are coming from the denominator. So you will have a positive divided by positive, right? Now, between 0 and 1, we can take half. If we take half, x plus what? 3 is still going to be what? X plus 3 will be positive, right? Yes. And this is going to be positive as well. And you have half minus 1, which is negative. So it means this is going to be negative. So if you take, let's say 2 in this interval, 2 plus 3 is positive, x is positive, 2 minus 1 is also positive. So this is positive. So now to conclude, you need greater than 0. So we take the positive part. So our solution set will just be what? Our solution set will just be from minus 3 open to 0 open as well, then union 1 open to where? To infinity. All right. Okay, so let's take the last question. The last one is this. You have the solution set. You're looking for the solution set in interval notation. So the same procedure. All you need to do first is what? We take everything to the polynomials or the rational functions to one side. So you have 4 over what? 2 minus x, then minus minus what? 3 over 1 minus x. This should be greater or equals to 0. And just like we did, you can multiply this by trying to make the LCD, the denominator the same. You can multiply this by 1 minus x times 2 minus x. And this you can multiply it by what? 2 minus x over 2 minus x, right? Multiply by 3 over 1 minus x. This should be greater or equals to 0. Now with this, you'll have 4 into 1 minus x minus, you can write it as 3 into 2 minus x. Then you see now we have the same LCD or the same denominator, right? And this we have greater or equals to 0. Then we just need to simplify. You have 4 minus 4x minus what? Minus 6. Then now you have plus what? 3x all over 1 minus x, 2 minus x. This is greater or equals to 0. Now, if you look at the numerator, 4 minus x will give us what? Minus 2. And we have minus 4x plus 3x. This will give us minus x all over 1 minus x, 2 minus x, greater or equals to 0. Now we can get our zeros. So what will be the critical values? Will be what makes the numerator 0. So now let's start with the denominator. We can see the denominator will be 0 when x is what? 1. And when x is what? And when x is 2, right? Yes. But what about the numerator? The numerator will be 0 when x is minus 2. So we have all of this. This is what we will take to the what? We will take to the table now. All right. So this will be the table. So let's have our number line here. So we'll start with what? Minus 2. Then what? 1 and 2. So let's draw this. Now we have to open the zeros coming from the denominator. And as you can see, both 1 and 2 coming from the what? The denominator. But since we have equal to 0, then at minus 2, let's keep it close. So what are the factors here? Minus 2 minus x, 1 minus x, and 2 minus x. So we take what's our test point. We take from minus infinity to minus 2, we can take minus 3. If you add minus 3 here, you have minus 2 plus 3 is still going to be it's going to be a positive number here. Put a minus here, 1 minus, so this become positive. Then 2 minus, this also become positive. So the result, the quotient, is just going to be is going to be positive. And then between minus 2 and 1, between minus 2 and 1, we can take what? We can take 0. If you add 0 here, you have negative. 0 here gives you positive. 0 here is still positive. So you have negative. Between 1 and 2, we can take 1.5. Minus 2 minus 1.5 is going to be a negative number. 1 minus 1.5, I'm substituting it here, is still going to be a negative number. Then 2 minus 1.5 is a positive number. So the result will be positive here. Then you take a number between 2 and infinity. You can take 3. If you substitute 3 into this factor, you have minus 2 minus 3, which is still a negative number. 1 minus 3 should be a negative number. Then 2 minus 3 is also another negative number. So the result is going to be negative since you have quotient of a negative number of negative. This is coming from where? This is coming from the numerator. This is coming from the denominator. So negative negative is positive. So you have a negative divided by positive, which will just be negative. And now our answer will just be, because we're interested in the part that is greater than equals to 0, so we take these two parts and this one. And you see that will be from minus infinity to minus 2 closed union. This part is 1 to what? To 2. And that is why we have this is the right solution. Here is the right answer. This one. Okay, so I hope this tutorial is clear uh, on how to solve rational inequalities. So if you are new to my channel or you have not yet subscribed, kindly do that, and turn on the notification bell, and also share with your friends. Thank you for watching.